like to start with a bold statement. Every business is a digital business, and information technology is driving the innovation that your business needs to differentiate and compete. There's really no question about that. Digital business means essentially that you're driving your business via software. And if you can't deliver software fast enough to enable your business and to service your customers, then your business just can't deliver, period. Nowadays, it's about speed and how fast your business goes to market with those new ideas. The risk is that your business may be at the mercy of competition and disruptors, and if you don't jump quickly enough on the bandwagon, then it becomes really hard. Established companies and monopolies are being challenged today. And it's true that the access to public cloud resources over the past 12 years have dramatically changed and speeded up the pace of innovation. And organizations that expect to thrive in a digital environment must achieve an improved competence in software delivery. But how do you set yourself in a position to really innovate? What is it that you might want to consider doing first, second, and third? We're going to try to cover some aspects of that. Almost 2/3 of the 1,000 plus organizations that we surveyed earlier this year use an average of 2.6 IT environments. We had about 17% of the respondents here that used 5 or more IT environments. I think the maximum was 7. So half of them use public cloud resources in some capacity. More than a third uses private cloud environments, and about 19% currently leverage hybrid cloud. What's hybrid cloud? Hybrid cloud is basically the ability for your workloads to move across any infrastructure or any cloud. So the message here is that multi-cloud here is a reality in every one of our customers. So market trends show that due to the long application life cycles and the high cost of change, enterprise will be dealing with a mix of bare metal, virtualized, and containerized applications. And that's for many years to come. This statement will actually stay true even as the greenfield investment moves to a more container-focused approach. So you're always going to have some workloads involved in a private cloud capacity just due to where data needs to be located, or because of staff capabilities, or maybe some prior existing infrastructure investments. They need to comply with regulations, or even maybe the need for greater flexibility that the public cloud cannot offer, and the need to innovate, the need to spread. So users across IT and the business need to be served. And the key here is not necessarily a one-size-fits-all type of solution, like going all into the public cloud. In fact, there's very few companies that have gone all in, 100% on AWS or Azure. Therefore, having a private cloud component into your overall IT strategy is almost a given. It is also true that the lines between data, storage, and applications have become more blurry. And consequently, the infrastructure that supports the apps and the data has been impacted by orchestration and abstraction frameworks. Hybrid cloud and hybrid cloud management in particular is not something that your business should be interested in. It's actually more of a necessity these days. So here is a sample of pain points, quotes that we still hear today with many of our customers, whether they're in software development or IT operation roles or management positions. Why does it take so long for me to get my resource that I've asked for? I've entered a ticket. What's going on? You might also have heard some developers saying, well, but it works in my environment, works on my laptop. I'm not too sure why it doesn't work in production. Last night, the wrong version of a service was pushed, and it took down the customer-facing app for hours. And then you have this site reliability engineer who wonders why one of his applications that he supports perform so poorly under some load conditions. And then you have the business stakeholders saying, well, I know that IT is not going to deliver on what we need, so why don't I just go and pay someone else to do it and do some, basically shadow IT. So what are the probable causes for these pain points? And I'd like to tell you a story. I started my career in the Iron Age, when in order to get a new server, I would have to go out and procure a physical machine, get it racked, install it, plug it in. Then I would go and configure the whole thing. It would take weeks, sometimes it would take longer, depending on the complexity here. But now we live in the cloud age. So you want a new server, then you go to AWS or any other public cloud provider for the matter, and you type a few lines, and then you click on some pretty UI, and boom. You get new servers popping up and down like crazy. It's that easy. The question is, though, how do I achieve this capability internally? And how do I manage this? How do we make sure that we take full advantage of the cloud age? Because the problem is that our thinking about how we manage infrastructure is actually Iron Age thinking. And this is natural because this is what we have known for most of our time. So it's only in the last decade that, or so that the leading organizations have begun to enter the cloud age. We've got very little knowledge to base us on, actually. And to manage the cloud age, I need to embrace and use concepts such as infrastructure as code. And infrastructure as code really is a way of managing the cloud age. In fact, I would argue, as many of my colleagues do here, that if you're not using infrastructure as code principles and practices, for example, then you're not really going to benefit from the benefits of the cloud age. Right? You might as well not bother doing cloud at all if you're not going to change your processes. So infrastructure as code, for example, is really important. And there's a lot going on right now about containers, microservices, and how to orchestrate those things. And getting a continuous delivery system that's very, very important. I would even say don't even think about containerizing until you have that going, right? So infrastructure as code, the principles and practices that are associated to that, and how you use these tools is actually more important than just the containers themselves or the microservices.
Thank you, Stefan. And I want to talk a little bit about modern days, right? Like as you were saying, we've seen the evolution from the Iron Age days to where we are right now, and the point of the matter is that we have as organizations multiple infrastructure options. Some of those options with pluses, some of those with minuses. For example, right, a lot of enterprises out there, they still deploy bare metal and bare metal servers, and they have bare metal workloads. Now, what are some of the benefits of using bare metal? You could have a highest density and lowest latency, but using bare metal servers brings some drawbacks. They are difficult to manage at the scale, and hardware is expensive. Now, you have another option, and this is a really popular option out there, and it's virtualization, just pure virtualization. Virtualization gives you the ability to balance of low complexity and automation, but also brings some drawbacks to the table, like some legacy approach to network and storage that you still have to use with virtualization in a traditional way. Now, public cloud environments are a really popular option out there. Why? Because they are providing global scale and limitless resources. And please look at the slide we're putting this within quotes, because there is some limit, right? It's limit in constraint of where are you deploying, what service are you using, and even going a little bit further than that is what is your budget that you have to adhere in order to use this public cloud. But the drawback of public cloud is that you are still tied to a unique vendor, and the cost will scale at the same time that your workload scale. And at the end, the last but not least is the private cloud auction. And the private cloud auction is a good balance because it will provide you a scale and full automation. It will be able to be programmable in order to use compute, network, and storage resources, and you could use also commodity hardware. Now, the main drawback that we see when we talk to customers about private cloud adoption is the requirement of a change of culture and bringing new skills into organizations. So, but at the end of the day, there are multiple options that you could choose nowadays in order to host your workloads, in order to use your infrastructure. The next slide that I want to talk to is a little bit about the type of workloads and how these could fit into multiple type of infrastructure. For example, if you have a CPU-bound workload, where can this workload fit? Maybe bare metal, virtualization, or private clouds. But if you have a more scalable, a more agile type of application, that is not going to be a good fit for a bare metal deployment. That may be a great candidate to using a virtualization environment or in a private cloud or in a public cloud environment. So I have this conversation a lot with customers, and it's about targeting your workload and where you're going to put the workload. Are you talking about a disk throughput application? Where are you going to put that IO intensive workload? Taking those decisions matter because that will be what will help you change where your applications are going to live, where your workloads are going to live. Are they good candidates for public cloud or private cloud? Are they good candidates for virtualization platforms? So that is a conversation that you need to have as an organization when you are choosing the deployment infrastructure that you're going to use. Now, at the end of the day, you want to start with a modern, elastic, flexible, agile, dependable, highly available private cloud infrastructure MVP. And this is a topic of conversation every time that we go and meet with multiple customers, no matter the industry. And I like to bring up a couple topics. And this topic is about use cases. Do you require automated scale up and scale down for your application environments? Do you need fully automated service provisioning and lifecycle management for your application and your infrastructure? It is continuous integration and deployment required to streamline the development, test, and release pipelines of your applications. Will the public cloud be needed to augment in peak capacity requirement times? Are there strict data regulations and compliance standards that need to be met? Or do you just want to manage an infrastructure that you could actually measure resource and know what people are running at all times? So those are some of the questions that you need to ask when you are going to embark on the private cloud journey. And defining an MVP is a really important part of it, because a private cloud could provide you on-demand services. It could be self-service. It could be fully automated. So that is just some of the things that you should look when you are investing in a private cloud. Now, what are some of the benefits? And I was mentioning a couple before on the previous slide. And it's all about control, being able to create and customize your private infrastructure in order to meet your business use cases and needs. It's about reducing costs for the infrastructure and operations. It's about privacy. You own your infrastructure, you own your data. You should be able to secure your servers in your data center. It's about providing continuity in order to avoid the concerns about vendor stability or longevity. And it's also about availability. How can you provide those components in a highly available way to meet your SLAs.
Thank you, Julio. So adopting cloud technologies is not easy, right? And we argue that it is about the technology on it itself. In fact, in every cloud implementation project, technology will only get you halfway there. And it's by unifying the right people's skills, the proper evolved processes, with combining with the technology that your business will be successful with the adoption of cloud and private cloud in particular. So what does that mean? It means that the architecture of a technology stack must respond to the desired user experiences that the business leaders, so whether it's the CDO or the VP of IT, is trying to deliver to the internal customers and to the external customers. But it also means that deliberate changes to the staff roles in the organization, as well as the critical workflows and the processes, may be absolutely required to address how the services are provisioned, how the infrastructure is being managed, and how those services are actually built in the new product. Right, so hopefully that makes sense here in what we're trying to do. So I'd like to give you a few, I would say, a summary of some of the concepts and the best practices that consist of the infrastructure as code. Number one, your infrastructure is defined in human-readable text files. Every change for your compute, network, and storage infrastructure must be described in those definition files. And basically, this is so that you can basically stand up your entire environment, with that code. And that code should be in a definition file. The second one is you really don't want to rely on a brave sysadmin or any type of tribal knowledge for your critical environments. Everyone deserves a break or a holiday, right? So your infrastructure and the way you conduct changes basically must be well documented and understood by your staff. And guess what? This documentation should live in the text files that describe your environment that you've created. And basically your documentation should be in your infrastructure code. The third one is, well, no matter what, your environment will change, right? And maybe it may change on a daily basis, right? That sounds kind of be crazy for infrastructure, but it's possible, right? And therefore, everything that makes your cloud environment, your definition files, everything must be versioned and checked in a version control system, right? And so that's for you kind of a reference point, and just to go back to a point in time with, what version of configuration did I use for that specific environment here, and how I'm going to be able to fall back on my feet should something go wrong. Everything needs to be versioned. The other thing you need to do is make sure that you continually test the systems and processes. Every change should basically be submitted and subject to a series of tests and validation that runs continuously. Why? Because you want to have your kind of like a dashboard of features and tests that are working, and if things go red, you want to catch it very quickly so that you can actually resolve your failure very quickly, as opposed to actually do big changes, right? And not be able to find what the root cause of the problem is. So do small changes, and that's the fifth point here, rather than batches of changes, so that you can actually restore from failure very quickly. The last point is number 6 here, is that's one of the very important practice here, is that, okay, well, there's no such thing as maintenance downtime. The expectation is it's always up, right? So how do you do that, right? How do you keep your services continuously available here? That you got to make sure that, your application can survive, loss of power, loss of virtual machines, loss of, pretty much every condition here that happens on your cloud, so that you can keep your services, your infrastructure services, continuously available.
So let's review another important component. I don't know if you remember a couple of slides ago. We have like 3 columns: the people component, the technology component, and the process component. I want to call out the people component, because when you are adopting cloud infrastructure, and when you are modernizing your practices, the most important component is not just the technology, right? It's a combination of people and processes, because you need to be able to reshape behaviors in the way that you are going to do things from that moment on, right? And this is a big topic that I see across multiple industries, and usually is one of the toughest things to accomplish, and it's reshaping behaviors. It's like getting the people that have been doing the same thing for the last couple years to change the way that they operate, to change the way that they think. So that is super important. The other part is to be able to set initial goals and objectives, aka the strategy component. Defining a cloud strategy is super important. In the last webinar series that we did last year, we talked a lot about cloud strategy, and cloud strategy is a super important component, and including the people side in your cloud strategy. How are you going to train people? How are you going to do your hiring? How are you going to change and influence the culture of your groups is an important component. Another part is offer the right methods. Being able to offer the right methods and the right tools and the right mindset on your teams will have a really huge impact in the way that you are doing business, in the way that your cloud adoption works. And that will help you to get to the last point of this slide, that is to expand the technology adoption process. And remember, at the end of the day, it's all people. People is the one that are going to be doing the job, are the ones that are going to be defining strategy, are the ones that are going to be adopting all these new technologies. Without the people component, you won't be able to succeed. And private cloud adoption or public cloud adoption or hybrid cloud adoption won't happen without getting the right mindset and the right people to be on board on this solution. Now, that is not everything, because I want to put an example of how to accelerate that adoption process. And this is more on the middle column, on that technology side, right? It's like when you have people and you have process together, and then you want to start working and investing on technology. Like, how do you get there, right? And these are really couple examples. Is being able to get people to use your platforms by providing self-service catalogs, being able to adopt platform as a service or container as a service technology that will allow your developers and your users to innovate. It is also the adoption of agile methodologies. It's investing on CI/CD pipelines, not only for your applications, but also for your infrastructure. It's about also investing on test automation. On the right side of the slide is a lot of our products and some of our partner products, but it shows some of the journey that we see in a lot of our customers on this change toward being more agile, toward being more cloudy in a matter of say. And it's from adopting agile development technologies for the application and for your infrastructure, to use tools like Jenkins, to do automated tests, to do continuous integration and continuous deployment of your infrastructure, of your applications, and use tools that could help you facilitate the interaction with your users, like platforms to offer service catalogs, Ansible for automation, OpenStack to provide the agile private infrastructure. So it's a combination of multiple things that will help you to accelerate your cloud adoption.
Yeah, that's true, Julio. And in fact, when I think about this, right, think about reshaping behaviors and adopting new processes, like things like, hey, should I allow my sysadmins to still SSH to the infrastructure when I have all this automation and all this configuration, that are happening automatically in the back, right? You may want to think about, hey, do I need to have some policies around, hey, can my guys actually go and change things? Because if they do things manually, is that change going to be reported into your definition files and things like this? So that's an example. So what I'd like to do now is basically provide you an example of the journey that we've had with one of our large customers in the financial services industry. And the goal for the CTO that we were dealing with, right, was basically to equip its software engineering department with a modern private cloud for renovation and standardize, the methods, the platform, and the tools to achieve consistency and really accelerate software delivery. Right. So the journey can really be decomposed into 5 major increments, and each increment basically has a finite set of objectives and outputs that can actually be measured during the engagement. So if you look at this, right, it's like a kind of a year and 3 months long engagement, right? That applies for large organizations, right? Because realistically, things and change, on the technology, but also on the people and process side, typically take time, and the larger organization, the greater it is. With this said, each increment gives you measurable output, and for example, in that journey here, what you get at the end of the first 3 months is basically a functional infrastructure as a service, and with running a container orchestration platform that would be implemented by us, by Red Hat Consulting, and and that cloud will be in place and ready for use. That cloud could also have its first containerized application running on top of it, right? And we would basically be ready to move on to the next increment. Next increment really is, now that you have this cloud here, how do you get to some more of a controlled minimum viable product, deployed, and where you actually have the development team, basically the users of the cloud, and the operations team, completely, I would say, onboarded, but also enabled on the new set of technology, right? Comes the next increment here is like, okay, well, now that we have, this core teams enabled here, how do we expand that to other teams? How do we promote, some agile practices that have been developed as part of that MVP here? And how do you get to basically instantiate on further automations, on more workloads, and basically get those onboarding process for additional applications prioritized? Continuing on that journey here, you get to the assimilation phase and getting to complete stability of the platform, getting all your critical workflows that consist of, not only design deployment, but also change processes, where basically those processes and the specifics of your applications are automated, and basically the onboarding of new applications is now globally enabled across your staff. Then comes to the handover, whereby the team that accompanies you through that journey, can basically hand over to the development and operations team on the customer side, and basically where you're in a state where any new applications are introduced at any time, these applications can scale and be retooled without any delays, and basically you have a state where the container adoption are well established. So that slide here is basically showing you kind of a condensed version of things. The way we would start typically is, assemble a target team on the customer side, pick 3 or more, minimum viable products, so basically chunk of work there, and basically gradually introduce agile concepts as you go, celebrate wins and repeat. So what you see here is for every increment here, basically the service components that align to this, and basically just depicts the journey. Obviously, every customer is different. That was applicable for one of our customers, a large bank, as I mentioned, and that was specifically tailored for their needs to standardize their methods and tools around software engineering development, right? Using a private cloud infrastructure that turned out to be on Red Hat OpenStack.
Thank you, Stefan, for showing how the journey could be. for this modernization process. Now, Red Hat Dynamic Infrastructure Solutions, and I'm going to talk a little bit about products. This is usually what we see during this process on the infrastructure side when customers build the MVPs, and it's everything from our foundation product, Red Hat Enterprise Linux, to Atomic Host, Red Hat Ceph, Red Hat OpenStack Platform, Red Hat Virtualization, OpenShift on top of OpenStack of Red Hat Virtualization, and then the management portfolio. But one important part here is going beyond products, and is the value and the expertise that Red Hat Consulting could bring to organizations. And we've been doing this for a long time, and we could help you continue the journey of transformation. And Stefan, do you want to talk a little bit about how can we help our customers with consulting services?
Yeah, absolutely, Julio. So we do have a framework, right? And in Red Hat Consulting, and that framework basically is based on an iterative approach, which basically starts with a discovery session. Actually, if we can move to the next slide, and where we're going to then design and address the outcome that you need to leverage your investment. And then once we've done the initial design, then we're going to implement a set of technologies and the integrations that are required for that minimal viable product. And then what we do is basically we repeat that process for as long as we engage, and we basically break down the work into chunk of work, right, that are very finite with finite outcome. Usually it's sprints. And we enable your team and basically try to complement the training that they got through Red Hat Learning Subscription, and we provide basically mentorship on how to basically try to do or redo or redeploy the Red Hat products or the Red Hat infrastructure by yourself. And so basically what we do is also we enable you to actually leverage Red Hat technologies to best suit your needs. So the discovery session basically is that 1 day effort or 2 days effort, depending on how large your organization is and your goals are. And what we're going to do is that we're going to send a couple of our architects, Red Hat infrastructure architects or cloud architects. And what we're going to have is basically an interactive session to really understand the problem space, what the solution approach is, and get to next step recommendations in a way that basically align your challenges and your requirements with Red Hat technologies, and basically also outline the overall problem domain and make sure that we understand your current state very well, where you want to be in your target state, and what are the opportunities to address in order of things. So we basically provide a technical introduction to the Red Hat cloud infrastructure products that are part of the engagement. And then what we're going to do is basically derive into a roadmap, right, that really is going to address things in order, right, that makes logical sense based on your...
We'll start off with introductions. I'm Bob from Widget Inc.
I'm also Bob from Widget Inc.
And today we want you to imagine that you've just started a job at a new client site or at a new job.
Yeah, let's imagine that you need some infrastructure. So to accomplish the work that you're going to need, you're going to have to eventually get some VMs or some infrastructure somewhere. So you probably want to start with the team lead. So let's say I'm the team lead. You're going to come to me and you're going to say, hey, I need some infrastructure. How do I go about doing that? And, well, I have been removed from the process for a while, so I'm going to send you to a team member who does know how to do this.
And I'm your friendly team member, Bob. And, well, the first thing I'm going to ask you is, do you have the virtualization infrastructure you need to actually be able to do this task you've been assigned? And assuming you don't have that, then I'm going to send you over to the virtualization team to go get that.
Okay, great. So now you're at the virtualization team. That's me, and you need to make a request. But we've got a little bit of a backlog, and that takes some time. But before you can even do that, I need you to talk to the security team, and we need to find out if you're even allowed to get this infrastructure. So we'll talk to the security team.
All right, so I'm the security team, and it turns out, okay, so it looks like you've got all your paper in order, but before you can really move forward, you're going to need to get this whole thing approved by the change control board. They actually only meet every week and a half or so. So in 6 or so days, you'll be able to go meet with them. So why don't, you can go talk to them.
Great. So welcome to the change control board. I see you've talked to a couple different teams. Luckily, you did catch us pretty early, so it won't take too long to get all this approved, but we only meet every so often. Once you're finished with us, you're ready to go back, do your request, and actually request your infrastructure. I think you need to talk to the virtualization team for that.
So yeah, welcome back to the virtualization team, and it looks like you've got all of your virtual infrastructure approved now to actually go do it. We're going to need a few days to do that, 5 or so. But then once that's done, you're going to need some DNS, I'm guessing. We don't handle that. So, in this new job of yours, you're going to have to go over and talk to the DNS team to get that done.
Hey there, I'm the DNS team. Looks like you've got a bunch of your ducks in a row at this point. You got your virtualization, but now, of course, you need DNS entries. Well, we're pretty slammed because we do everything by hand manually, so it's going to take us about 5 days. Once we're done, though, you're going to have to talk to the OS team, and they're going to have to get some tools installed for you.
All right, so I'm the OS team, and I can help you get all that installed. Of course, we're pretty busy too. We got lots of people coming out of requests. Lots of people start at the same time as you. So, we're probably going to need 5 days or so. Yeah, it's automated with some scripts we've got here and there, but it's still going to take us a few days. But then once we've actually done all that, you're going to have to make sure the system that we configured for you is still actually passing all those security rules you promised you were going to follow. So you better go back to the security team and make sure they validate everything.
Great. Welcome to the security team. Looks like you've got some DNS entries. Your infrastructure's there. You talked to the OS team. Well, now we have to do the validation. We've got some scans that we do. They're automated. We also have some manual checks that we do. Take us a little bit of time to work through this. But once we're done, we're allowing you to actually touch our network, and you're probably going to want to talk to the load balancing team because you don't just want one of these things. You want to be able to hit all of them. So go talk to the load balancing team.
So it looks like you got your security validation done. That took 5 days or so. Luckily, it only takes us a couple days on the load balancing team to get your load balancing request finished. But once you're done with that, you need to go do your final validation with your product owner and team lead again.
Great. So now we're going to do the actual validation. Now you got some virtualization. You talked to the security team. You met with the change control board. You got DNS entries. You're cleared by the security team to actually touch the network and start doing things. So that looks pretty good. And, you're a new guy. It only took you about 42 days. Honestly, I've seen it a little bit longer than that. I've seen it a little bit shorter than that. 42 days is about average for us. So you did pretty good there. That's not too bad, right? You're happy with that?
Well, if I was that new person who just started, I'm probably not very happy, especially when I realized that I forgot a server and I need to go request another one.
So it sounds like somebody didn't design their hypercloud for the end user.
Yeah. So, we should probably work on making that a better process. So, that scenario we just walked through is maybe a bit of a hyperbole, but it's something I've run into in the field as a senior architect for Red Hat Consulting. Cameron, is this something you've actually experienced as well?
Yeah, it absolutely is. Unfortunately, we see it all over the place.
And I actually started my life as a developer before I kind of moved into consulting and then architecting. So I definitely understand the pain points of people wanting to be able to deliver value to their organizations quickly. What about you, Cameron?
Yeah, as you mentioned, so I'm a consulting architect. I've done a lot of the same things. I spend my time working with customers trying to tie all of the different puzzle pieces of their infrastructure together via hybrid cloud automation. And unfortunately, we see this way too often. So what we're going to be talking about today is a process that you can use that we've found, that we've implemented for customers that will help them work through this, help them design their hybrid cloud for the end user. And it's going to be an agile process. It's cyclical. There's going to be multiple iterations. First and foremost, though, we need user input. We need to talk to our users. We need to figure out what they're looking for, what works in the current infrastructure, what doesn't work, and how do we start fixing it. To do that, we're not going to send an email. We'll get into some actual strategies to fix that in a little bit. We need to sit down with them and actually solicit feedback because the users are at the center of this. After we find out who our users are and what it is that they actually want, we need to design the solution. This is where the tools and the technologies and the different paradigms come into play. Are you going to do VMs? Are you going to do containers? Are you going to allow for self-service? As you're doing this design, it is imperative that you always design for production-ready systems. And not everything is going to be in the actual production environment, but what we mean by that is that you're designing something that's going to be useful, that's supportable, that's maintainable, and can be used for a long time within your organization, and you're going to iterate on that. Well, after you've designed the system, you probably want to evaluate your policies. What we talked about earlier, that hyperbolic example, a lot of that was based on policies. There was change control boards, and there were security teams, and there was a team for this and a team for that. Well, you have to make sure that you're not blocking the users. What you're providing them actually needs to be useful, and you need to evaluate the policies that you have in place right now to make sure you're not hindering that progress. And, of course, we're still going to be maintaining our information security practices, but maybe we're going to make it a little bit easier to actually get infrastructure. And then, and this is my favorite part, you're going to do the implementation. This is where you're going to take all of that stuff, you're going to put it into practice. There's tons of webinars on doing this implementation, so watch some of them. But at this point, you've really just built out a small piece of your infrastructure. Here is the most critical piece of all of this. You're going to request feedback from your users, and you're going to iterate. And you're going to do this again and again and again. So, Ian, help us find out, why do we care about these users, and who are they?
So yes, this is going to be a very user-centric process. So the first thing we're going to have to do is identify those users. So, one of the first users you might think of is your infrastructure admins, your traditional ops team. They're going to be the ones building and maintaining this hybrid cloud, but they also might be using it to provision systems they need. One you might not think of is your C-level executive. They might not be going into your hybrid cloud to provision a VM, but their mission is to help drive the value of the business, and all these other users are going to be using your hybrid cloud to do that, so that makes them a user of the system, if even only indirectly. Your security team, again, like the ops team, might be using the hybrid cloud to deploy security scanning tools, but they're also going to be a builder of this hybrid cloud, which makes them a user. If you're building it, you're also a user of it. The procurement office. Right, so if you're going to build a self-service hybrid cloud that's going to allow users to provision VMs or containers on demand, then you're going to maybe burn through hardware or public cloud infrastructure faster or slower than you're expecting. And so you need to kind of be in line with how you do quotas and limits to make sure that you're not over or under burning on what you can procure. And of course, there's the engineer in the field, so the person actually using software that's running on top of your hybrid cloud is going to be a user you need to talk to about what they need out of the system that's supporting them. And the developer, right? So the developer is the one creating your business applications that are running on top of your hybrid cloud that are delivering the value of your organization or business. So we need to talk to all of these people. So how can we go about doing that? Cameron, how would it work out if I just kind of emailed all of these people on like one big CC list and ask them a bunch of questions? Is that going to work out for me?
Yeah, everyone loves it when you reply all to a couple hundred or a couple thousand people. No, don't do that, Ian.
Yeah, okay. So if I can't do that, how about I schedule a lunch and learn or a lunch conversation on a Friday and invite everyone into one big room during lunchtime on a Friday afternoon and try to ask everyone together a whole bunch of questions about their experience and what they want out of the system. Will that work very well?
No, that's not going to do it.
Okay. I'm a pretty good team lead, and people like me, so how about I just start texting everyone on my team and all these other people, and we're giving them phone calls and ask them, on the weekend, like, what do you want out of this hybrid cloud initiative we're going to start building?
Yeah, I like you, buddy, but don't talk to me on the weekend.
All right. So what if I invite you into a one-on-one discussion during normal business hours and ask you some questions about your experience and what you want out of a hybrid cloud so that you have a safe and open space to communicate what you actually feel without the fear of what other people think about those opinions?
Yeah, that sounds good to me. You'll definitely have my attention, and I'll be more willing to be candid with you about how I actually feel.
Right. So the point here is that it's important to have very targeted one-on-one conversations with your users. Not even doing small groups, like literally one person talking to one other person. And it'll be kind of clear in a moment because we really need to start figuring out once we have the user attention, then we need to kind of move on to the next step, right? So we've got the one-on-one attention. What do we need to do next, Cameron?
Well, we know who our users are, and we know how we're going to talk to them. Now it's pretty important if we actually get them to tell us what they want. You know, who would have thought? If you don't ask them, you're never going to know what it is that they're actually looking for. So it's great that you identified them, but you never actually asked them, so it doesn't do you any good. Well, we come up with a couple questions, and this is just a guideline that you can use to talk to these users. First and foremost, you want to talk to them and ask them, what do you want in order to accomplish your task? This is a wish list. This is pie in the sky, but let's figure out, stretch goals, what it is you actually want to accomplish your task.
Right, but then it's also important to ask, what do you need, right? Needs and wants are different, right? So as a user of a hybrid cloud, I might want to be able to provision any number of VMs, any number of CPUs and memory I want, whenever I want. That would be great for me. But what I actually 100% need is a way to quickly get access to a virtual machine or a container. And some of that other stuff is more of a want, right? So separating those two things is going to be important as we move into the design phase.
Yeah, and on top of that, you want to find out the current most annoying technological pain point because your users are going to have them. There's something within your technological process right now, within your provisioning process or your self-service or your reporting or whatever, that they are not going to be happy with. And the sooner that you can identify what those pain points are, the sooner you can start addressing them. But it's not just the technology.
Right. So, like that example in the beginning, the problems there weren't technological, they were policy and procedural based. So it's really important to ask people, what is the thing that's getting in your way today from a policy and procedural point that's preventing you from delivering value to our business or our organization? And again, that's another reason it's important to have that kind of as a one-on-one conversation so people feel more open to answering these questions openly.
Yeah, and last but not least, these are the people in the field. These are the people that are using this thing every day or they're affected by it. Talk to them. They have ideas. They have coworkers that are at other places where they've read blog posts or they've seen TV commercials of other solutions that are working awesomely. So talk to them. Find out ideas about what it is they have. Maybe they'll help you do your job. Maybe it'll make your life a little bit easier. And after you've talked to these users and you've asked them these questions, and again, this is just a guide, something that Ian and I found helpful, here's where you need to take all of that and move into the design phase. This is where you've solicited feedback. You got a pretty good idea what they like now, what they don't like, and you're going to know what it is that people want to see. Now, let's actually talk about designing this thing. Ian, can you walk us through that?
Absolutely. So, my initial approach to designing might be, I have in my mind what I think the users want. So, Cameron, you're my users, and this is what I think you want. Let's pretend you could sneak into my head and see this. Is this correct?
No, that is not correct. I don't know what type of human being will fit on that swing set, but that's not going to work for me.
Yeah, and then there's the problem of, okay, so I actually go to you and I describe it, and what's the likelihood that I kind of describe it to you looking much more like this, sunshine, rainbows, padded? That's probably a pretty likely scenario of how, even if I've got that other image in my head, this is how I'm going to describe it to you.
Yeah, that's amazing. If you can deliver me that exactly, I'll love you forever.
Yeah. And then, it's probably pretty likely that I'm going to end up delivering this for the first iteration, which even in my own head doesn't line up. And are you pretty happy because I described it the other way?
No, I'm not happy with that at all.
Yeah, and then it turns out that this is actually what you had in your mind, right? Which, some combination of all of that, and it's not actually even possible because I see that you want it for free, and there's always going to be some kind of time involved at the very least. So there's going to have to be some kind of negotiation here as we start doing this designing. But how do we really need to start figuring out, okay, so we know that there's going to be possibly mismatches between the design and what the users want, and that's why we're going to ask them all the questions. But then, why are we really so focused on designing for that user? Why is this important? What happens if we don't start thinking about how to design for the user, Cameron?
Yeah, this is really important. If you don't design for happy users, you're going to get this thing called shadow IT. Shadow IT is when the users still have their job to do, but you've hamstrung them by process or poor technology choices or whatever, or they just saw some bright shiny thing off in the distance and they decided they want to use it. Well, they're going to go use that thing instead of working within your policies. And that creates many issues. That makes it difficult to do reporting. That makes it very difficult to do auditing. You have no idea what the information security is like on that other side. So you want to avoid shadow IT completely, because what it really means is you're not enabling people to do their job. And when people aren't able to do their job and they start missing deadlines, they become unhappy. And when people become unhappy, they're going to leave. They're going to leave digitally in the form of shadow IT. They're going to find another tool. Or they're going to leave physically, which is turnover. This is expensive. It leads to loss of talent. You have to do recruiting. Then you have to train all the new people, get them access to everything, and get them into your environment. We really want to avoid that if at all possible. We don't want dissatisfied users, but we want to design for a happy user.
Right, and you're not saying that, like, shadow IT isn't, it's not the user doing a bad thing. It's the user trying to deliver what they said they would deliver. It's trying to deliver value to their organization. The side effect is not always positive, but the intent is positive, and we need to view that positive intent and then avoid the negative outcomes by just designing for what the user wanted in the first place. And so, where does this all really stem from, right? And it stems from choice, right? So users have choice today. They're not locked in. So they can choose what they want, whether that's using your system or finding another path. So we want to build that choice in, and those choices are going to change over time. So we need to make sure as we're designing for that, we design with choice in mind. So I've got a scenario for you, Cameron, about a good way to design for choice and success. So we're going to start with our green field. We've got nothing. We've got a shadow of an idea of what we want. And then 6 months later, I will deliver you exactly what you wanted. We'll call it waterfall, and it'll work great.
No, I don't like that.
Yeah. Never in the history of the world has waterfall actually delivered what people wanted. So let's try another approach. So Cameron, you can continue to be my user. So we'll start with that same green field, and then you give me 2 or 3 weeks, and I deliver you this. Is this on the road to what you wanted?
Yeah, I mean, it's definitely not exactly what I want, but it's starting to take shape a little bit. I can see potential in that.
All right, so can I have another couple of weeks to try again?
Yeah, I'll give you a shot. You didn't go off for 6 months. That was only a couple of weeks. Let's see what you got.
All right, so here you go. It's your life and dream, a rope on a tree.
You're getting closer. It's not perfect, but you took a step in the right direction. So let's see. I'll give you another 2 weeks. We'll see what happens.
All right, I'm really excited about this next demo. This is the dream.
No, you took a misstep here. This is obviously not exactly what it is I wanted. It's not what you promised me. It's not how you described it to me. So, no, I don't like that.
She's going to walk me out the door and fire me and get really mad and disband the entire team?
No, you showed me that you have potential, and, we're still pretty early on in the process, so I'll give you another chance. We'll see what happens.
All right, so I'm going to go off and iterate a few more times. Are we getting closer?
Yes, we are getting closer. It's starting to take shape.
All right, so we're kind of doing small agile iterations here, which seems to get us to the solution you actually wanted.
Hey, look at that. Yeah, that looks pretty good. And it didn't take forever. I got to see progress along the way. Yeah, there's some missteps, but really that's okay with me because you eventually got me there.
Yeah, so this isn't a new concept, right? We're just talking about agile iteration rather than the old water-fail way of doing things. But what this really gives us, right, so we all talk about agile as being great, but why is it great? It's great because it allows us to design for choice. It allows our users to change their mind as we build our system to align what we're building with what they need at that moment in time. And that's why agile is important as we start to build out our hybrid cloud for our end users, because those end users, when we first talk to them at the beginning of the project, are not going to be the same 2 weeks in, 4 weeks in, 6 months in. So we need to constantly be going back to them, and the agile approach allows us to do that. There's also another concept in here that's probably important to cover.
Yeah, if we had to distill all of that down into one thing, we're going to follow the golden design rule. I want you to keep it super simple. That's it. You think you want the user to have all the options right out of the gate. You're going to go out for 6 months. You're going to build this thing. It's going to be so awesome. They're going to love it. No, don't do that. That's bad. Right? Start small. Keep it simple. Don't make a complicated UI. Don't make a complicated system. Enable the users to be successful, but don't overcomplicate things. You don't want to bog them down, right? We're doing agile. It's cyclical. It's iterative. We're going to talk to the users. We're going to figure out what they want. We're going to design it. We're going to deliver it. We're going to go back and we're going to do it again and again and again. And because we broke it up into small chunks and kept it simple, we didn't just waste 6 months of time. As you're going through this design, though, you want to make sure that you're thinking for the future, right? You are designing for the future. We talked earlier about making sure that the thing was production ready, even if it wasn't actually in production. This is an actual quote from a customer, and it's awesome because really what it says at its core is that technology is changing rapidly. You cannot escape the future. You need to make sure that what you're designing right now is going to meet your needs in the future, a year from now, 5 years from now, 10 years from now. But because you're breaking it up into small chunks, you're biting off a little bit at a time and you're iterating on it, that future can change. We're not starting a monolithic project that's going to take 5 years. You're going to get there eventually, as long as you make sure that you're designing for the future and you create things in such a way that they can be changed. They can be updated. At this point, we've talked about the design, though. It doesn't do us any good to design this awesome system, Ian, if we still have things in front of it that make it difficult to use.
Yeah, so once we've designed this system that allows us to be adaptive, then we need to make sure that our policies are going to be aligned with this adaptive system. So, let's talk a little bit about how, our existing process might have come into existence. So, a while ago, it might be that Carrie went in to retire one VM and accidentally retired 10 VMs. And there was a production outage for, a couple hours. And so now there's a policy on, only these 2 people on this one team can ever retire VMs. And which now means, as a side effect, you have hundreds and hundreds of VMs and containers out there using hardware that aren't actually being used because there aren't anyone to retire them. So, that was one policy that came into existence. And then, another time, Jose spun up too many VMs, and then there wasn't, that other policy prevented us from retiring them all, so now we're using all that hardware. So now we have a policy on who can actually spin up the VMs. And then, Ian and Cameron were like, well, we want to be able to load balance things, provision, storage, and, we want this widget here and that widget there. So now your UI has gotten super complicated because you've just bowed to every single whim that Ian and Cameron ever wanted. And then at some point in time, someone wrote some automation that was automatically upgrading all of your systems in production without anyone knowing. And now there's, a ban on using any automation in production because of that. And then, this one time, Courtney saw that the log file was getting really big on production. The disk size was about to run out. And so they zipped up the log file and took down your entire virtualization infrastructure production because that log file was actually the transaction log for the database. And so now you've got a policy about who can actually touch the virtualization infrastructure, and so it's very troublesome to get any virtualization work done in production. All of those true stories, by the way. So as all these policies build up, none of them had bad intent. None of them were put in place to say, hey, you know what I want to do? I want to build a 42-day VM provisioning process for the hybrid cloud. That's not what they were put there. They were put there because specific things went wrong and the organization was trying to address them. The problem is, among all of that, the user was kind of forgotten. So what we need to do is not necessarily get rid of all of those, but we need to start saying, all right, how do we think about this in the context of the user? How do we change the conversation from being policy-centric to user-centric? So while you still have all that history of what's gone wrong, you start thinking about, okay, so how are these policies protecting the user, all of the users, the CIO, the developer, the infrastructure admin, security team, everyone we've talked about. But as soon as you start asking the questions of how does this policy affect the user, you can start having much more productive conversations about, well, is that policy really helping solve the problem it was put in place to solve? And you can start reducing, policy and procedure gaps just by asking questions in that frame of mind, because everyone is always happy to have a conversation about how is this policy actually helping our organization? How is it helping the user? So just, think about putting your user first as you're having these conversations. But then, you might be building your first ever hybrid cloud. And so, and this might be a brand new net new system, like you're one of the lucky ones who got to do it greenfield. And so one of the questions you might ask yourself is, well, do we actually need to apply all of those policies that came into place because of things that happened on the old system to the new system? Do they even apply, right? These policies we put in place for virtual machines, do they really apply to containers? So I've seen organizations struggle over the years, like, well, we've got this policy about how you can spin up and retire VMs. How do we do that for containers? It's like, well, you don't, because they're containers. So trying to ask yourself, well, for this new project, is it time for new policies? Time to get rid of the old ones? And say, let's start from scratch on this project, on this hybrid cloud. We have all of our users, we know what all their needs are, and we'll design new policies specific for this system. So one specific use case for how you might do that, one way of thinking about this is, so you might have had an old system of saying, okay, so me, the user, I put in a request and I want 3 virtual machines. Maybe one's in the public cloud and 2 are on 2 different internal data centers. So there's, just like in our example earlier, those requests go out, and then I get the public cloud VM first because it's the public cloud, and that was quick. And then I get data center A back, and then I get the security scan results for my public VM, and then I get my data center B VM back, and then I get security bless for my public cloud VM, and then I get the security results for my data center C VM, and then I get that VM security blessed to go live in production, and then I finally get the same for my other on-prem data center. So the end result is I got all 3 VMs, but I got them maybe days or weeks apart, which means I couldn't actually start testing my application in a hybrid cloud environment for weeks, even if I got the first one in an hour. So we need a different way of thinking about this. So what do we do instead? Well, we have the user submit a request to the secured process, right? The secured hybrid cloud process, rather than individual requests that need to be approved for each individual request, and then we get everything simultaneously. So instead of thinking about securing each individual VM or container or data store or whatever it is, we think about, okay, so the security team is one of our users, and they're going to help build our hybrid cloud. So we can ask them, as we build this hybrid cloud, to allow users to self-service provision, what do we need to bake into that automated process so that whatever comes out on the other end when the user clicks the give me 3 VMs across my 3 hybrid cloud providers, that they can use it right away without any other people or process in the way, because we've done all the process and people work ahead of time. And that's the way to start thinking about it. But beyond just thinking about your policies, so you can deliver a a great hybrid cloud. So, Cameron, I went away, I did 6 iterations, and now I have that green button you asked for. It does exactly what you want. Here you go. Are you happy?
No, I'm confused. I thought we talked about the button being purple. I don't really know what to do at this point.
Oh well, you just click on it and it turns purple like you asked. Did you not read the instructions?
No, I need some more help. Can you help me out here?
Yeah. So the idea here is that if you don't train your users, it's not going to work out very well for anyone. Even if you design exactly what they asked for, each iteration isn't going to have everything they asked for. So they're going to have to understand, well, how do I use, this partial system? And then, even when you're trying to keep things simple, it might be simple to you, the designer, the person who's implementing it, but whenever it gets in front of a user, whenever you actually put it in front of them, there's always some things that aren't necessarily as intuitive as you thought they were. So as part of each iteration, as part of each deliverable, part of that should be, okay, here is that new green button you asked for, and here is how you use it, and not just a 500-page PDF. Like, do demos, do sit-down workshops where people actually get to use the system with someone else in the room to help. Anything you can do to actually train them so that everyone will be happy, and no one will start eating other people out of frustration. So now, Cameron, that we've figured out how to address our policies, we've trained our users, we've designed our system, I think we're ready for your favorite part.
Yeah, like you said, this is my favorite part. This is hands-on keyboard. We've got all that boring stuff out of the way. Let's talk about this technology. This is awesome. Well, Ian, let's talk about some of the things that we need to consider in this. There's a lot of cool stuff out there. Probably the first thing, let's talk about maybe CI/CD. I want to be able to deploy this thing, and I've got apps everywhere. And yeah, I want a CI/CD process to make this super clean and smooth.
Okay, yeah, but we also need to talk about provisioning, how we're going to provision everything that the CI/CD process is going to be built on top of.
Sure. Yeah, I also got these databases in my environment. I got to figure out how to manage those, and what do all my schema look like? Am I doing NoSQL or SQL, or how do all these pieces fit together? How am I actually storing all this stuff?
Right, but I really want to make sure we talk about how we implement technology to do self-service. So we've got to cover all that.
Yeah, that's fine. We've also got virtual machines. Doesn't do me any good to have this awesome process if I don't talk about what these things actually look like, how to deploy them, and where they are.
All right, so we've also got to talk about how we're going to integrate like our on-prem providers and our public cloud providers and our databases and our provisioning and our CI/CD. So we have to talk about the integration of all of this technology.
Sure, fine, but let's not forget it's all about the app, right? This is where it all comes into play. This is where we make our money and we show our value in the market. This is where middleware comes in. I have to be thinking about that.
Yeah, I mean, your middleware is important, but it doesn't really do any good unless, even your stateless app still has state somewhere. So we're going to have to talk about the storage, software-defined storage, fiber storage. We're definitely going to have to talk about that.
Yeah, but what about my containers? I heard about these awesome things. They're containers. They're fast. They spin up. They spin down. They do awesome things. I care about all of that, and I want to make sure that I have containers in this environment.
Right, and containers are great, but didn't we just spend quite a bit of time talking about how we really need to make sure we're focusing on the people?
Yeah, people are important. And what about our process and our policies? We just spent a long time talking about that. Those are definitely very important.
Yeah, so we're going to have to focus on that too, and the teams and training. We already know that's important. So as we're talking about all this technology, we need to make sure we're keeping all that in mind.
Yeah, and there's the design and planning of all of this. It doesn't do me any good to build this awesome system if I have no idea, if I didn't design for the future, I didn't design for production. That doesn't do me any good.
And the bedrock of all this technology is compliance and security, right? Now, all these technology things we're talking about, every single one of them, we need to make sure we're talking about the security and the compliance in my industry or my organization or my government. So we're going to have to keep talking about that as we talk about all these technologies.
Right, and then how do we actually do all this stuff? This is where things like DevOps and Agile and sprints and my demos, that all comes into play. That helps me tie all of these different pieces, the technology and the people in the process together. But Ian, it's almost like there's a lot under the surface that you can't see when it comes to this stuff. Maybe it's almost like an iceberg.
Yeah, Cameron, it's almost like that if we don't pay attention to everything under the surface, that our organization is going to have troubles with that before we ever start talking about technology. And we're going to fail before we even start.
Wow, interesting. So how do we fix that?
Well,
this is where things should get boring.
Yeah, we focus on the people and the process and the planning. We focus on everything below the surface to build that base for all that technology on top.
Exactly. So here's where we iterate. We're going to do this whole process over and over and over again. You want this to be boring. You want to get into a rhythm. Because, to be honest, if this iteration is exciting, that means calls at 2 in the morning. And nobody likes that. Nobody wants a text from their boss at 2 a.m. or, severity 1 ticket that comes in that has to be addressed right now in 15 minutes or else we'll get fired. This is the iteration. It should be boring. We've already talked about all the different pieces. How do we know what we're doing actually makes sense, though? This is where we solicit our users' feedback. We know who our users are. We've talked to them, figured out what it is they want, they need, their pain points, their ideas. That doesn't matter at all if you don't actually talk to your users and get their feedback.
Right.
I mean, if you had to distill all of this down to one simple thing, what would it be?
Yeah, I mean, so Cameron, you presented a really good framework of a process in the beginning. You know, we focus on the user, we go to the design, we talk about policies, we do the technology implementation, and then we go back to the users. But even that's quite complicated. So I think I've got a simpler idea. You start with you talk to your user, you listen to what they have to say, they feel happy, you feel happy, done. How does that seem? Can you remember that?
Yeah, I think I can figure that out.
Yeah, so this is the one takeaway, everyone, right? To succeed at technology, whether it's the hybrid cloud or containers or whatever you want to talk about mixed in there, the key to the success is don't just go build a system for you. Go build the system your users need by going to the user, asking what they want, listening to what they have to say, and then doing it again and again and again. So
there's one thing to remember if you take away from all of it. And I know this really smart guy who said this thing once, and he said, you will never be done building your cloud.
And I know this even more awesome guy who said, but as long as you focus on the end user, you will succeed. So now we have some time for some questions.
Great. So thanks, everyone. First and foremost, if you have any questions, please use the questions and answers box on your screen to go ahead and ask those. We have a couple questions already. We're going to go ahead and run through those. So, Ian, this first one is for you. We got some great feedback. It says users want everything yesterday. That is always the issues, and the user doesn't actually know what they want. Ian, how can we address that?
Yeah, I mean, that's really where those questions we talked about in the beginning come in to help guide the conversation. Because you just go to them and be like, tell us what you want. Of course, they're going to say, I want it yesterday, I want no cost, and I want 10,000 widgets, and I want it all tomorrow. So you direct the conversation with, kind of, you don't have to use that exact framework we talked about earlier, but something along those lines to kind of solicit more poignant feedback, separate things into priorities in your mind, and then you can have more honest conversations as you iterate. That first demo, they're going to be like, well, I asked for all this, and you only gave me this. It's like, yeah, well, we're going to come back with more, and are we on the right path? And you'll find, or at least I've found, that in doing it this way, everyone remains happy, right? Whereas you just say, tell me everything you want, and then you come back 3 months later and you don't give them what they wanted, then you kind of have this mismatch and people kind of get annoyed. But if you keep it small and you iterate, you keep asking those questions, you keep expanding your user base, at least in the experience I've had so far, it's worked out. So, to that point, Shannon, we got another question here about this is all great in the abstract, but an example of actually doing this for real. So I know you've implemented this process before many clients. So can you give us an anecdote of one of the times you've done this with one of your clients?
Sure, absolutely. So just thinking through the past here, I had a customer in the past, and they were going to be getting a new cloud platform and some management tools on top of that from Red Hat. And because it was new to them, it was a technology that they'd never worked with before. They were used to the old paradigm, their old infrastructure tool set. It was a bit scary, and they were concerned about having to learn all new things. And to address that, we made sure that we were in constant contact with them. We were doing sprints. At the end of every sprint, we would do a sprint demo. But on top of that, we found out that our primary end users were going to be the systems administrators, and we made sure to work with them hand in hand to design the system. Where does this thing fit into your current environment? How do you do things right now? We sat down with them for a full half day and just whiteboarded and hashed out everything that they're doing right now at the moment, so we could talk about where these new systems would fit in the future. And then as we started doing the implementation, we had them drive, and we worked over their shoulder to actually do that implementation. And because they were doing the driving, they were doing the implementation with our guidance, it was hands-on training. They were learning the system as they went, and we were able to get real-time feedback from them as we worked along. So we really took this system, and we went through that full process, and at the end of it, we had a system that they were pretty happy with and that they were able to manage on their own because they were the ones that had actually implemented it with our help and our guidance. Ian, another question that we've got here, though, is this is all great, but how do we talk to our users, our end users, and figure out who they are if we've got 5,000 of them, right? Let's say we're a big organization. How do we do that at scale?
Yeah, so that's a really good question. If you go through that process of identifying who your user are going to be, and you end up with thousands of them, well, you can't go have 5,000 one-on-one conversations and have a productive solution come out of there. So it's a game of figuring out, all right, who's going to be our first users, because you're not going to have 5,000 users day one of a hybrid cloud or really any new IT project, right? You got to roll it out in phases, especially as you're introducing new functionality, because you're not going to have the functionality for all those users at once. So you can start to think, well, this team here is going to be likely the first ones to use this new project, and maybe get a point of contact on each of the teams. So you don't have to talk to all 100 people on your security team. Find the one or two who have the bandwidth who are going to be matrixed into this build out and talk to them. So you just got to kind of narrow your focus to those who are going to be initially participating, who you're initially building for, and then you scale out from there. You build for their use cases, and then as you've got their use cases kind of solidified, then you add in another set of users and start building out their use case, and you add another set of users and build out their use cases, and eventually you are kind of listening to the collective voice of 5,000 people. But then it kind of, as you're doing this, right, you're collecting those users, and that's how you get to that scale. So, Cameron, another question we've got here is how do you balance, iterating quickly, getting the work and getting the work done fast. You've got your rock star developer, and you could go put them in a hole and they could get your first set of work done in the first 4 days, versus kind of being a little bit more strategic and following the process. How do you balance those two things? Basically, speed versus process.
Yeah, it is a fine line, and Ian, we're both from Red Hat Consulting, and so customers will bring us in because they want smart people on these technologies to go and deliver it for them. But I know in my experience, it's not enough to just come in and implement this thing and leave, right? Then you haven't done any training with your users, and you don't know who your actual end users are. You haven't maybe designed the system correctly. That's why it's so critical to, yes, you can iterate quickly. You can do this continuous integration, this continuous improvement by working with your users, but to make the products and the new technologies and the thing that you have spent all that time and that money building sticky, and make sure that it stays around and you don't get shadow IT, you have to be doing that mentorship. You have to be doing that knowledge transfer with the people, and you need to be doing sprint demos, and you need to be including everyone. And there are ways to do that quickly. There are ways to iterate on this very fast. Those things that we talked about today, they don't take a lot of time, but they are a worthwhile investment. You're spending potentially lots of money and lots of time to roll out this new system. You want to make sure that you do it right, because if you have somebody just come onto your doorstep and drop off this black box, and they say, here, go use this, it's going to solve all your problems, well, what happens when they leave? Who maintains that thing? How do you get new features in it? Right? Somebody within your organization needs to figure out how to use it, and that's where this process comes into play.
Yeah, I mean, I think that it really comes down to the dichotomy between doing it, what you perceive as quickly, and doing it in a more process-oriented way is actually a false choice, because it might look quick, but it's not actually because of all those things you just mentioned. Yes, you'll have a short-term win that will get you through the next weeks, the next months, maybe the next year, but your long-term outlook, you're just going to be going back and redoing the work eventually anyways. So this whole thing we're talking about through this entire conversation has really been, this isn't a process for you to adopt for the next 2 weeks or for next month or to iterate just your next hybrid cloud. It's really what we kind of said at the end there. This is to set up a process to continually build your future forever, because the future is just going to keep coming. So this isn't like you do it once and then you're done. You're just going to keep building and building and building. We're never, as technologists, all of us, we're never going to be done building. We're always going to have that next thing to build, and we're always just going to keep iterating and building on top of each other. So it just keeps going from there. Would you agree, Cameron?
Yeah, absolutely. And it looks like that's all the questions that we've got for now. So Ian, if somebody who watched this webinar wanted some help with all of this, could you tell us a little bit about maybe how Red Hat Consulting could help?
Yeah, absolutely. So one of the services, I perform and you perform, Cameron, as Red Hat Architect, is that if you're kind of interested in having Red Hat help you out, both with technology and with process, but you're not necessarily sure on where to start, you can always, reach out to Red Hat and ask for discovery sessions like, hey, we have this general business problem that we would like to solve. We're not quite sure how to solve it. We'd like to talk to you about how you might help us do that. And we'll come in, we'll have, detailed discussions on what the business problem is, how you've already looked to address it, what ideas you might have in mind. We'll actually walk basically through this process with you in a short cycle to then, talk about how we can help in the long term with pointed projects.
So first off, let's talk a little bit about OpenStack. OpenStack is a combination of open source software services that work together in unison to create pooled resources to run and manage a private cloud. 6 of these projects handle the core cloud computing services, and they are compute, networking, storage, identity, and image services. And while more than a dozen optional services can be added after, in addition to those core components, to create unique deployable clouds. The Red Hat OpenStack platform gives enterprises an open foundation to deploy, scale, and manage private clouds. It combines Red Hat Enterprise Linux server and kernel-based virtual machine into a secure infrastructure, a combination that allows users to run OpenStack nodes, such as compute, storage, and management, like a public cloud, but in a private environment.
And the second product that we have today is OpenShift. OpenShift, as you probably know, is a container as a service type of product. It means that OpenShift can manage networking, storage, and compute, but the compute piece is provided by containers. So OpenShift is an orchestrator of containers that has the capability to also set up networking and storage for these for your applications running as container. The other distinctive property of OpenShift is that it exposes a declarative API, and that means that as the user of OpenShift, you specify a desired state for your infrastructure that you are deploying in OpenShift, and then OpenShift knows how to make it happen. OpenShift is based on Kubernetes, which is, as of now, the de facto standard for container orchestration and the de facto standard as a platform to run container native applications. But OpenShift and also Kubernetes do not only run modern container native applications or function as a service type of applications. They can also be used to run legacy and stateful workloads. And from what I see in the field, there is a trajectory in how an OpenShift deployment evolves. We usually start with a small footprint because enterprises wants to see how it works for them, and then maybe grow from there. And so usually we deploy OpenShift on VMs initially, and then if the engagement is successful and the company likes OpenShift, that footprint will start to grow. And with many customers, we reach a point where we have to decide whether we start building more clusters or whether we start building clusters with larger nodes, so larger capacity. In either case, the objective is to have more capacity because, as I said, they want to deploy more applications. And in either case, you have more orchestration to do for the underlying infrastructure on which OpenShift runs. And this is where we see that OpenStack can help either way you decide to grow your infrastructure. OpenStack can help setting it up and coordinate that infrastructure.
Okay, so let's start this slide by talking about some of the abbreviations that we've shown on the last couple of slides and are referenced at the top of this slide. We've got OCP, which stands for OpenShift Container Platform, and then we've got OSP. And with that, we're talking about OpenStack Platform. You'll also see that second one listed as RHOSP, which is Red Hat OpenStack Platform. So you'll see those used throughout the rest of the presentation. In this slide here, we're trying to illustrate how these different components fit together. If we start at the bottom, those are our OpenStack hypervisors. Those are the hypervisors that run the workloads, in this case virtual machines. Each of the red boxes that you see on the screen, and they're different shapes. You've got the tall ones on the left and the kind of square ones on the right. Those all represent virtual machines. So in this environment, we have different virtual machines with OpenShift components that are doing different roles. So the ones on the left, the tall ones, those are what we call our master servers. So they're virtual machines that are running the services that are listed there. The API service, the controller service, scheduler, and etcd. And Raphael will talk a little bit about how those services are used, right? If you look on the right side, at the top you'll notice that the infrastructure nodes also run a set of containers or services, right? And then down at the bottom,
real estate, but as you know, you can have as many nodes as you want. All of this infrastructure is provided by OpenStack, including the necessary networking, load balancing, DNS, and storage. You can find more detail. This is an eye level, obviously, a diagram. You can find more details on this reference architecture. At the end of these slides, there are a couple of links that will take you there. The other thing to remember is that we have created an automation to build this infrastructure with an Ansible playbook. So if you start with an empty OpenStack tenant, you can actually create all of this infrastructure and install OpenShift on top of it just by running a single playbook. And you can also hook post-installation steps to maybe initialize the cluster or customize it with your particular needs. The other thing to know is that Kubernetes is, as you probably know, is a plug-in type of software where many of the functionalities can be plugged in. And in particular, there is a cloud provider plugin. This is a piece of software that allows OpenShift, or actually Kubernetes, to talk with several cloud APIs. So there is obviously one also for OpenStack, and the responsibility of the cloud provider plugin it mainly falls into three domains. One is to create a node inventory by creating the underlying cloud provider API, and that's needed to understand not only which nodes are part of the cluster, but also where they are, if the cloud provider gives you some topology additional information. And then the cloud provider plugin will create VIPs to load balance traffic directly to the pods. And then it also has the ability to dynamically provision storage. So by using the storage API of the cloud provider, you can create volumes that will be attached to the pods. But with OpenStack, we went beyond these capabilities, and so we have some additional integrations. So in the slides on the left, we see the integration with OpenStack that are provided by the cloud provider plugin. So as we said, storage, Cinder for block storage, and Manila for file storage, and then Swift is available, but it's not intermediated by OpenShift. Then we have load balance as a service for creating VIPs. And then we have the ability to query the cloud provider API and understand the topology of the nodes that comprise the cluster. And then we have some additional integration. We have the possibility to use DNS as a service. This is not mandatory, but you can turn it on. And that will give names to the VIPs that you create or to the VMs that you create. And then we have the ability to integrate the two SDNs that both OpenShift and OpenStack use to a single SDN through the Courier plugin. And then we have the ability to support both bare metal and virtual machine type of nodes, and the ability to dynamically scale nodes if your cluster is running at capacity and needs more capacity. So for storage, we're going to analyze these integration points, these touch points between OpenShift and OpenStack. For storage, as I mentioned, we have the ability to use block storage, file storage, and object storage. In my experience, as your footprints of application grow, you will encounter all of these three use cases. So it's better to create a roadmap where you will actually provide this capability to your OpenShift cluster. And if you are running OpenShift on OpenStack, you just have this capability since the beginning. The other thing to remember is that what we want to enable is dynamic provisioning of storage. This is the ability to self-service storage from the developer point of view. So a developer can say, I want 3 GB of storage for this application, and the volumes that will contain that storage are automatically provisioned by the cluster, by OpenShift talking to the underlying platform. We find this to be an essential ingredient to a successful OpenShift initiative, because essentially it removes a friction point between the developers, the OpenShift administrator, and the storage administrators. In this case, there is no need to create tickets, there is no need to send emails to have storage created. You just can create storage in a self-service way, as I mentioned, and obviously there are checks and balances in place, like a quota system, to make sure that you don't use more storage that is allocated to you.
So let's talk a little bit about the load balancer as a service. We point out that this is load balancer as a service v2, referring to the API version 2 for load balancer as a service. It's much more fully featured than the original release of load balancer as a service. The components you see listed on the screen are the parts that make up the service, right? You've got the load balancer service itself, right? And from there you can define listeners. As we're showing, maybe you can listen on port 80 for HTTP traffic, and you can create another listener to listen on port 443 for HTTP traffic, all under the same load balancer, right? Then you have the ability under that to create pools. Pools are the member servers that are going to receive the requests. And you have the ability to take those listeners and direct them to one pool or multiple pools. And then with those pools, so you have flexibility to direct that traffic where it needs to go. The other components you see are the health monitors and the members themselves. The health monitors are constantly pooling the member servers to make sure that the service that they're supposed to be providing is healthy. And if it's not healthy, it'll mark that member as not available, and the traffic will be directed to other members automatically. So a fully featured load balancer, all the bells and whistles we need to host highly available applications are built right in.
And if I can add a comment here, when this comes to play in the OpenShift world is when you create a load balance type of service, OpenShift service, which is a type of service that allows connections from the outside world into the cluster. The default type of service in OpenShift is the cluster IP type of service, where the load balancer gets an internal IP or VIP, but that is just dedicated to internal traffic. This enables you to connect applications, connect and load balance application from the outside world into the OpenShift cluster.
And the last bit there is the two different types of load balancers that we support today. We have Octavia, which is a virtual machine-based load balancer that's provided built-in with OpenStack, and then the ability to use pluggable load balancers with LBAS v2. You could bring your third-party load balancer, for example, and configure it to be a member of your cluster, and the load balancer as a service will connect to that load balancer and configure it for you to do these features that are listed on the screen, and you can use it that way. So all the different things that you need, whether you're bringing your own load balancer or whether you want to have OpenStack supply a load balancer, you can go either which way. On the next screen, we talk a little bit about DNS as a service. This provides a REST API for domain and record management. It's got built-in multi-tenant support, right? So you can have DNS zones and domains that are specific to your tenant that another tenant can't manage, which is essential in a multi-tenant environment. It integrates tightly with the OpenStack identity service and includes a framework for integration with the compute service and the networking service, right? And what this does is it automatically will create and delete DNS records for virtual machines or bare metal machines as you spin them up in your environment. So you don't have to go anymore. If you employ this service, you get the ability to create records manually. If you wanted to create a special record, you could just call the API to do it, but you also get the automatic functionality. Whenever you create a new VM, it's going to put a record in your DNS for you. Today, the Red Hat OpenStack platform has integration support for the Bind 9 DNS server.
And one comment on what Brent said, the multi-tenancy support from OpenStack is a really interesting feature, because if you think about it, it allows us to create multiple OpenShift clusters that are completely isolated in different tenants, if that is what you require to do.
All right, next we talk about Courier. OpenStack likes to create, really creative names for things, right? So Courier is an effort that's focused to be the courier that delivers neutron network services to the container runtime, right? We want this for a couple of different reasons. It helps us avoid double encapsulation. It'll help us manage each container port as a neutron entity. And we've got planned support for many neutron SDN providers, OVN, MidoNet, Dragonflow, and so forth. We can leverage neutron advanced networking features such as load balancer as a service, firewall as a service, security groups, and NAT. Basically, it takes the OpenStack ports and plumbs them all the way through to the OpenShift containers, which is avoiding the need for a separate SDN layer or any other kind of encapsulation over the top. So, I'm not sure what happened on the title of this slide. I think this was supposed to talk about bare metal provisioning via Ironic. So another cute name from OpenStack. There's a bunch of them. But the OpenStack bare metal provisioning service, Ironic, provides the components required to provision and manage physical bare metal machines for end users. It uses Pixie to provision the physical machines on demand, and then it'll return those machines back to inventory after you're done with them. So if you needed a physical machine to do a test case and you wanted to build maybe a database server, you could request one of these physical machines. It'll go out and provision it for you. You can use it for a day, a week, a month, whatever, and then your use case is finished. You're moved on to the next project, right? And this was just for development purposes. So you delete the machine out of OpenStack from your tenant, what looks like a virtual machine to your tenant, and it goes out and actually pulls that bare metal machine back, wipes it clean so it doesn't leave any of your data on it, and then puts it back in inventory so the next user that needs that type of physical machine can request it.
The last feature we want to talk about is the ability for the OpenShift plugin, cloud provider plugin to query, as we said, the inventory of the nodes and understand a little bit about the topology of how the cluster is distributed across potentially zones of OpenStack. So OpenStack has the concept of availability zones or failure domains, and if you spread your OpenShift cluster nodes across these domains, obviously you achieve higher availability. But you can inform OpenShift of this topology, and then OpenShift will deploy and schedule pods so that to leverage this additional availability. Basically, it will spread the pods across the availability zones so that if should an availability zone go down, then you still have your application running. The other capability that you get, and this will come a little bit in the future, but the other capability that it's enabled by this type of integration is the ability to realize when you're running out of capacity, so when your nodes start to be full, and the ability to provision dynamically new VMs to be joined to the cluster as new nodes, and therefore this way increase the available capacity.
So the next slide talks about a roadmap, a way to get started, right? How do you get started with containers on cloud? So this is a sprint schedule format. In sprint 1, usually these sprints are about 2 weeks long. So as you look across this, you think of these sprints as 2 weeks. And we get started with a design workshop. We bring in infrastructure, OpenStack, container, resources to talk to your team and do a design workshop to figure out what your use cases are, what the best way for you to utilize these products is going to be, who the key players are, all the stakeholders. We identify all this up front, and from that we create a design that we're going to use throughout the engagement to help you be successful. After that initial design workshop, we bring out our infrastructure consultants, and we build out the key infrastructure components that are necessary to deploy the entire stack, right? Mostly related to OpenStack, but it could also be a satellite solution for RPM packages like we talked about earlier, an identity solution maybe based on our IDM product, but mostly it takes a little bit to get OpenStack configured just the way that we want it, and what you'll be left with is a repeatable, deployable software or, infrastructure as code sort of deployment mechanism that you can keep in your source code repository just like it was a source code that will allow you to deploy our OpenStack product in a repeatable, successful fashion. After we start wrapping that up and we have maybe an engineering or development environment ready to go, and we start to bring up a production or staging environment, whatever your environment calls for, then we start to bring in other resources that layer on the container platform.
Yeah, and as you can see in this sprint plan, we start in a little bit of a staggered way. This makes sense, right? Because we need the OpenStack infrastructure to be at least usable to be able to install OpenShift. We have tested this configuration on the field, and we feel that it's pretty. We are confident that this is a good approach to this type of engagements. So talking about the OpenShift side of this engagement, we usually start with a set of workshops, deep dive workshops on OpenShift and design workshops. In this case, the design workshops are relatively easy because in most instances, we just reuse the reference architecture, but obviously we want to make sure that we build an OpenShift on top of OpenStack the way the customer wants. After the design is complete and we can start building it, the engagement splits in three main work streams. One is the platform build and operationalization. This is very similar to building to the one that we have for OpenStack, right? It's a build and then operationalization. We think that three sprints is a minimum amount of operationalization to take you to a production-like environment. This stream could continue for a longer time, and that applies to all of the streams. But this is a type of engagement that we propose to get started. The other streams are about running applications inside of OpenShift. So we usually select a couple of candidates applications just to showcase that you can port your workload inside of OpenShift, or that you can develop new greenfield workload to be run inside of OpenShift. And the third work stream is about creating a CI/CD pipeline, because it's obviously it's a best practice, but we also want to showcase that you can reuse your existing CI/CD pipeline to deploy to OpenShift, or if you want, we can bring our own pipelines that are based on Jenkins and show you how you can leverage all the OpenShift functionalities to promote application throughout your SDLC, your software development lifecycle. And then, as you can see at the bottom, throughout the entire engagement, we do mentoring and documentation. In a way, the purpose of Red Hat's engagement is to become non-necessary. So we want to make sure that you gain enough skill to run these platforms by yourself. And obviously, we also document what we do in a deliverable that we call the engagement journal. And as I said, this is an engagement that represents a way to get started. In general, the trajectories of this type of engagement are that if you like what you have after this engagement, we will continue. But in order to continue, we will have to understand exactly what other objectives you have.
So the way it all starts is with the discovery session. We come out with some of the members of our sales team and our consulting team, and we sit down with you, and we start a planning session for what kind of use cases you have, what your challenges are, the overview. It's usually a half a day or maybe a full day session to try to get an idea of how we would devise a plan like the one on the previous slide. We're going to identify potential technologies and solutions, right, and list them out, and then we're going to create an action plan to address those opportunities. Kind of ties it all back in together. So it starts with a discovery session. We come out, we sit with you, we talk with you, and then we put a proposal together that that will help you understand how we would like to engage and what the different steps and checkpoints are in that engagement.